Section 2.2, we're going to be looking at equations of lines. Slope is a big indicator when we're dealing with lines. It's found with the formula m equal y2 minus y1 divided by x2 minus x1. Now m is the letter we use to represent slope. x1 and y1, x2 and y2, those are just points on the line. We give them subscripts to distinguish one from the other, but it doesn't make any difference which point you call your first point and which point you call your second point. What does matter is when you're doing the subtraction in your slope, you have to be consistent. So if I use the y value from this point first and then subtract the y value from this point, in the denominator I have to follow the same order. This x minus the other x. Slope is commonly referred to as rise over run, and that's because if you look at the formula, you subtract the y values, that tells you the difference in the height, so how much it rises, and the x's when you subtract, that's how much you move horizontally, or the idea is that's what you would run. Lines with a positive slope will slant upward from lower left to the upper right, and then of course if you have a negative slope, they go downward from the upper left to the lower right. Some special lines are vertical and horizontal lines. A line is vertical if and only if it has undefined or no slope. Now, the reason for that is vertical lines have the form x equals a, where it's just some number, like x equals 7, x equals 6. That means every single point on that line has the exact same x value. And if you think about the formula for slope, where you subtract the y's and then subtract the x's of points, if the x's are the same number, when you do the subtraction you get 0 in the denominator. So that's why it's undefined or no slope. Now a horizontal line does have slope. It has a slope of m equals 0. So watch your notation and your terminology with this. Vertical lines have no slope. Horizontal lines do have a slope of m equals 0. Horizontal lines have the equation of the form y equals, usually we use the letter b, but it's just some number. Y equals 7, y equals 8, y equals 9. And just to make sure that you've got things straight here, vertical lines, those go straight up and down. Horizontal lines go straight left and right. You can think of it as it's across the horizon. So the general forms of lines that we have, the point slope form, y minus y1 equals m times the quantity x minus x1. Now again, m is the slope, x1, y1 are the coordinates of a point on the line, x and y are just the variables x and y, because the equation needs to have those variables in it. This is the equation that I typically use when I'm asked to find an equation of the line. You may have been taught to use a second equation, and we'll use that some as well, but when I'm asked to find an equation of a line, my main focus is I need a point and I need a slope, and then I can use this formula. Something else that can help you memorize this formula a little bit, if you think about our formula for slope, it was the difference of the y's divided by the difference of the x's. Now there, of course, we had specific numbers for 2 different y's, 2 different x's, but if you divide this equation on both sides by x minus x1, you still have that same idea of the difference of the y's divided by the difference of the x's. Again, the main difference is here y and x are just y and x. They are not numbers. The only numbers we would have are the y1 and the x1. Now the slope-intercept form is also a form that we're going to use. Many times equation or problems in the textbook will ask you to rearrange the equation and put it in this form. Notice that m, the slope, is the number that gets multiplied by x. B at the end is what's called the y-intercept. Now if you think about how we find y-intercepts, you always plug in 0 for x. Well, if this is 0, that means this whole quantity will be gone and we'll be just left with y equals b. So the slope is m, the y-intercept is b. Your textbook lists a general form, which is a constant times x plus a constant times y equal a constant. I don't plan to use this form very frequently, but you may have equations that start in this form. So the last thing we need to discuss is the relationship between lines, and in particular lines that are parallel and perpendicular. So two distinct non-vertical lines are parallel. When we look at their slopes, they have to be the same. So the reason we have to throw in non-vertical is because, remember, vertical lines do not have a slope. Now you could use the same idea and think to yourself, oh, well, if one line doesn't have a slope, the parallel line must not have a slope either. And that gets us to this part, that two distinct vertical lines are parallel. So if you need a line parallel to a vertical line, it's going to be another vertical line. Okay, so again, we have to throw out vertical for this situation, but what if we want perpendicular? Two non-vertical lines are perpendicular if and only if the product of their slope is -1. If you multiply the two slopes together, you get the number -1. Now, often what we do is we say that means their slopes are opposite reciprocals. So if one is positive, the other is negative. If one is negative, the other is positive. Okay, and reciprocal means if one slope is 4, the other slope is a -1/4 when we throw in the opposite sign. If one slope is a -3/2, the other slope would be a +2/3. Now what about vertical lines? So again, we had to throw vertical out of this because they do not have a slope. Well, lines that are perpendicular to vertical lines have to be horizontal lines, and vice versa.